Give me a countdown when you're ready. Okay, welcome. We're glad to have you here. It's a little hot. Okay, fantastic. This is a 101 track. We're going to talk about leveraging the dark side. Hopefully, you're all ready to get a slew of code information and some good stuff. First of all, my name is Jeremy Cox. I am the Network and Security Manager for Washington County School District. That's my website right there, supertechguy.com. You can find this presentation along with some code and some different things that I made available as part of this presentation on my website at supertechguy.com. And that is my employer's website if you're interested. All right, so in this presentation, we will examine how to leverage a portion of your address space to monitor and mitigate attacks. We will discuss custom logging, and this will be focused in kind of the Palo Alto world. Can it be applied to other worlds? Absolutely. But in this presentation, I will show you how to do it in Palo Alto. From the Palo Alto Firewall to a Linux log server. We will discuss creating a custom dashboard with these logs. We will also discuss how to turn those logs into a list of IP addresses. And we will discuss the uses of dynamic address list on the Palo Alto Firewall. And then we will also discuss using access lists to block traffic from those addresses. So there's a lot we're going to cover today. We've got almost a full hour to cover it. If we get done early, then we'll take a Q&A at the end. But otherwise, we'll just keep on moving forward. Okay. So technologies used in this presentation, as I stated already, Palo Alto Firewall. We'll be talking about syslog NG, which is an open source system logger. Apache, we'll use PHP 7, HTML5, and Ajax. And yes, it may work on others, but today I'll show you how to do it on these. So, first of all, what is a darknet? Many of you have heard the term darknet. No, we're not referring to the Tor network. Okay, in this particular instance, we're not referring to the darknet. We're talking about a darknet that you're going to build on your own networks. A darknet is basically a section of addresses, an address space with nothing on it, something that has no DNS records pointed to it, no servers on it, no references to it in any way, and preferably has never had anything on it or hasn't had anything on it in a very, very long time. So the idea being that you've got some addresses that there is no legitimate way that anybody should ever really be talking to them. And if they are talking to them, it's because they shouldn't be there. Okay? That's the idea behind this. And what is the purpose of a darknet? Mostly to catch automated scans. We're looking at people who are going through your network with either Nmap or any other number of scanners out there, some script kiddies or just automated scans that are looking through your network, looking for resources to hack and exploit. And so the purpose of the darknet is to see those scans as they come in on your network in a controlled environment, and such that you know who's doing it, what they're looking for, and ultimately have the ability to do something about it. So, to build a darknet, how do we do this? Well, first you need to determine how large of a darknet you need. Okay, and this largely depends on what kind of IP structure you're working with, how many addresses you're working with in your organization. For example, if you have a /16, for some of you that may be astronomically huge. For others of you that may be small. So if you have a /16, a /24 might be enough for you to do this. Or you could do two 24s or two 25s. I mean, you can kind of build it as you please. If you've only got a handful of addresses, you may just say one address is your darknet. That's the one address that nobody should ever be talking to. So build your darknet according to your size, and then make sure that it's giving you what you want. Okay, whatever you have to spare. So how do you build it out? For example, assuming that 10.0.0.0 was /16 was actually public address space, which it's not. But if it was and not private, you would want to start possibly at the beginning of that address space and potentially also at the end. So the idea being that if somebody's going to sequentially scan you, which by the way, that's not always how it happens, although that is the default behavior, that you would see them before they hit your network, not while they're in the middle of your network, if that makes sense. Okay? Or not before, but at the very beginning. And if your address space is non-contiguous, then at that point you kind of have to work it in. And it's really up to you. You have to kind of look at it and say, okay, if somebody's going to scan my network, at some point along the way, I want to be able to stop them and block them and keep them from coming into my network. So plan it wisely, think about it tactically. How does it affect your network? How would they look at your network? How would they see it? So let's go right into the config. So on the Palo Alto, the very first place that you're going to start is you're going to create a darknet zone. Now this is basically an identifier that says, hey, I am going to take and build in a zone in the Palo Alto that I'm going to call it darknet, and then we're going to assign some things to that. You're going to take, by the way, all these slides will be posted on the website, so don't feel like you have to do it all while I'm talking. I'm going to walk you through it, and you can take it back and do it later if you'd like. After that, you're going to tie your darknet to an interface. It's important that it is actually tied to a specific interface, even if there is literally nothing on the other side of that interface. Okay, so you can create a virtual interface, you can create an interface that is a sub-interface, whatever you want to do with it, but tie it to an interface, and then you're going to attach it to a virtual router, and then attach it to the security zone darknet. Okay? Once you've done that, you want to go into the IPv4 section or the IPv6 section and assign it that address space. So if you've got multiple address spaces, you would put all of those address spaces in there. You're going to have to do the back-end routing on the device that's in front of it. If it's doing dynamic routing, then the Palo Alto will talk directly to it. If it's not, if it's doing static, then you're going to have to configure the routing to make sure that that network hits that firewall, if that makes sense. But you're going to attach it to that particular address. And you're going to do it on the Palo Alto. And then you're going to create a syslog server profile. Now in the Palo Alto, you have to do several different things in order to make it actually get to the point where you can send syslogs out to your syslog ng box. And the servers, so you go to a syslog server profile, create a new profile. You can call it what you like. You're going to then add the name of the server. You're going to put the IP address in the syslog server. You're going to tell it that it's UDP, assuming that it is, on 514, which is the default syslog port. And then you're going to set that. After that, you're going to go into the custom log format. And we're going to actually use a custom log format, and I'll show you why in a minute, why we use that. Because in the end, we're looking to do something that looks kind of like that. Now that's really, really hard to see because it's really, really small for you guys. And I'm trying to remember. There we go. Maybe that's a little easier to see. So we're looking for something like that, okay? And if we put it to a custom log format, you can create a dashboard that shows where the scans are coming in and then ultimately what's being blocked. And I've actually distributed the code that's available on the website to do this, and we'll walk you through kind of the steps to set this up. But essentially that's kind of what we're after in this presentation, along with the blocking that's actually happening on the other side. So we go in, we set a custom log format, and it's going to look something like this. We can actually go into Palo Alto and we can say, hey, I want to use the scan from, and then you're going to $source to $destination, DST, and then we're going to pipe in the protocol, the destination port, and if perchance the Palo Alto identifies the app, which it usually doesn't because this is not actually going to be talking to anything, I throw the app in there just in case. Then you're going to create your custom log forwarding. Okay, so you have to create a log forwarding profile. Once you've done that, you assign it directly to the syslog server profile that you created earlier. Okay. Same thing here. Create your custom log forwarding. This is the next screen that it brings you in. It basically pushes it to that syslog server. And afterwards, you need to create a policy. So in your policies, this is something you want to put probably at the end. You can put it at the beginning. It really doesn't matter because nothing else should be hitting that. It shouldn't, well, actually, it's probably better at the beginning, to be honest, and I'm not sure why I put it at the end. I'll have to change that slide. But in the end, what you want to do is a catch-all that anything that hits that address space gets stuffed into this policy. It's critical that the policy catches everything that hits there. So if you've got other rules that could potentially let things in, then this is why you would want to put it at the beginning. So you go to source, you say the source is the outside, because we don't want to necessarily catch internal traffic and start blocking that. The destination is the darknet, okay? So that particular zone that we've assigned it, and then basically, based on the interface tie and assigning that zone to that interface and assigning those IP addresses, it will only catch things that go to that interface, to that zone. And then we're going to do an action, which is deny, and we're going to put it, the log forwarding is the critical piece here, because this is where we want to say, send anything that happens here over to your log server in that custom format that we declared. Okay? So then we go into syslog-ng, and at this point, your Palo Alto should be forwarding logs to your syslog-ng server that looks something like this. Okay, so you should see logs. I've commented out the IP addresses. Now in the code, it's doing that as well. You notice that on the screen. Okay. That'll actually show IP addresses for you guys, but I did that for this presentation. And it shows that there's a scan from a certain address, and it's going to a certain address, and then the relevant information about that scan. Okay? So you should see those logs start flowing in, but now at this point we want to actually filter them. So syslog-ng has a really cool function in which you can actually go in and you can say, hey, I want to filter how these logs flow in and what files they go into. So we want to, in this etc syslog-ng conf-d directory, we want to create a file and call it darknet.conf. Okay? And at the very top of the file, we need to start with a sources, saying any syslogs coming in on UDP, this is how we're going to work with them. So we have a source, and then we need a destination. So this is basically the file that we're going to stuff all these logs into. In this case, we're going to create a destination called df-darknet, and the file we're going to put in varlog darknet.log. We're going to assign the owner as root, and then the group as www.data, or whatever is running the group on your web server. Okay? This is a critical component. You might go, well, why are we giving the web server access to this log? Well, that's important to do with this. Okay? The web server needs to be able to see those logs and at least read them in order to be able to generate this kind of log file that's tailing. Okay? So we're going to start with that, and then we're going to create a filter. So the filter, basically, it can start as easy as this. If you have only one firewall that's basically peeling these logs out, and that's a recommended practice. If you've got a firewall that you can spare that can do this, that can be kind of a lab firewall, darknet firewall type environment, then that's great. If you don't, and it's just hitting your main firewall, that's fine too, but you're going to have to get a little more detailed. So in this case, what we're saying is, in this first one, I've only got one firewall. Any logs that are coming from it are from the darknet. Otherwise, you're probably more likely to want something like this. Well, it's coming from this firewall, okay? There's the net mask, and in syslog-ng, you're going to have to make sure you use it in CIDR notation. So a /32 is a single host, okay? So you just put the IP address of the firewall, where it's going to be sending it from. Now, the firewalls have multiple interfaces sometimes, so you've got to make sure you know exactly what IP address it's sending it from. And then the message scan from or message threat from, you notice that language that we used when we created that custom log format. Okay? And we did that on the firewall when we created that. So it's looking for those key words coming from that firewall. And then lastly, we're going to tie it all together with a log declaration. Now what this does is it says, if the source is UDP, run it through the filter, darknet, that we just created back here. Okay? There's that filter. Okay? And if it matches this filter, then stuff it in the destination df darknet, which we declared right here, which means that it's going to stuff it in this varlog darknet.log file. And that's ultimately what we're trying to do here. We're trying to take all of your logs that are being collected by this darknet policy and stuff them into that file. So at that point, you should have a file that shows up in varlog grep darknet. Okay, it called darknet.log. And then you want to set up a log rotate, obviously, because otherwise what's going to happen is that file is going to get massive. All right. So we're going to create an etc log rotate darknet, log rotate.d darknet file, and in it we're going to stuff in this information. So in here you've got your darknet.varlog darknet.log, and you're saying I want to rotate it every 14 days. Well, basically means that for 14 iterations. Okay, I want to keep 14 iterations of it. I want to do it daily. Okay, and the rest of this stuff I won't even worry about. But essentially, what you're going to end up with is you're going to end up with 14 log files. Okay, that's 2 weeks worth of darknet information, and it's going to rotate them on a daily basis. It will also compress them. Okay, so if you get older ones, they're going to compress it, so you're not going to be using up tons of disk space. So that will make it rotate daily. So after 14 days, you'll have a set of files that'll look like that. Okay, you have to wait 14 days to see that many. But after the first day, you should at least see darknet.log, and the second day, you should see darknet.log.1. And if you're seeing that, then you'll see the rest of the files shortly. Okay. So in Apache PHP, you're going to want to go to supertechguy.com/training. Okay, and there I've got posted all that information regarding the PHP code. We're not going to go over all of it because there's no point in boring you with a whole bunch of lines of code more than I already am. You're going to pull the log-tar.gz, and in that tarball is all the code to run this. And in the end, you should get something that looks like this, although you won't have this bottom section right here. Okay? The code's fairly explanatory. Feel free to reach out to me if you have any questions or concerns or frustrations with it. You're also going to pull a PHP script called darknet_ips.php. And this particular script is used to basically build that list. Okay? So the Palo Alto has to have the list of IPs in a very specific format. And the cool thing about this is once you start to figure this out, you can start to feed additional IPs from other resources and from other systems where you detect compromises. And so building this system is really advantageous to you as you start to expand on it. So in that file, and I will show you the code on this one, essentially all it's doing is it's a PHP script that runs when the Apache web server calls it, because Palo Alto wants to have a file that they can pull right off the web. And all it does is it executes a couple of shell commands. And it basically cats out the darknet log file. Now, it has a couple of options. What it does is it allows you to pull multiple pages. So you can pull up to 14 pages, which gives you by default, it'll give you today's blocks. It'll give you, if you do page 1, it'll give you yesterday's blocks. If you do page 2, it'll give you the day before's blocks, and so forth, okay? And so there's a couple of different logical operations that happen here, but essentially what it does is it cats those out, and then it basically uses awk to take and peel out just the IP addresses. Then it sorts them, and then it gives you the unique addresses. That's all it does, because what happens is when those IP addresses are hitting your network, you're going to get multiple logs, sometimes hundreds of logs, from the exact same IP address. And the last thing you want to do is feed the Palo Alto a whole bunch of duplicate IP addresses. So this essentially peels out all those duplicates by first sorting it and then running them through unique. Okay? And then basically what you get is something that looks like this. So this shows today's malicious hosts. To go backwards in time, use the page variable. Okay? Example, index.php, question mark, page equals 1. And this is page 0. If you did use page 1, it'd say this is page 1. But it shows the first few IP addresses that my network has detected as malicious. So part 2, we go back to the Palo Alto. We then go in and create an external dynamic list. External dynamic lists are very, very cool. They're very, very easy to use. And they allow us to basically pull lists from online. Now, there's lots of sources out there on the internet for these types of lists that you can pull online. Do I recommend you use them all? Some of them, maybe, but be very, very careful. So this is a word of caution. Anytime you start to set up dynamic lists, you got to realize that somehow somebody who needs to use the service, who's supposed to use the service, might accidentally get blocked. Okay? Now, the nice thing about darknets is you shouldn't have anybody who's legitimately needing to use the service ever talk to that network. I mean, realistically, it shouldn't happen. Does it happen? Yeah, it might, but it's really unlikely. Now, there are other IP block lists out there that occasionally somebody will show up on that list that was supposed to actually legitimately use your service. So be very careful how you implement these. Be careful how you go through it and monitor what it's pulling off. Also, realize that you do have the capability to do exceptions. So if you have blocks of addresses, you say, I don't care what shows up in here, I can always I always want to talk to this block of addresses. You can do that, and the Palo Alto will accept that exception. So essentially what you do is you go in here, you do an IP external dynamic list, you type is IP, an IP list, and then you put in your source, which is just the HTML, okay, where to find that page. So you're going to say, you're just going to put HTTPS, and the name of the server, and that PHP script that you're pulling. Yes, in fact, that's exactly what you do. So depending on how long you want to block for, okay? In my case, I block for 3 days, okay? But you could block for 2 weeks. Or you could go in that log rotate and you could make it last for, instead of 14 days, you could do 365 days. You could block for a full year, which is a little extreme, okay? But you could do it if you really wanted to. You could also change the way that log rotate works, and you could do lots of different things and not have to do it in 365 files. But essentially what you do is you create 3 different dynamic lists. Darknet scans 1, 2, and Darknet scans current, and then you can do this as many as you like, and then you can basically put in the page numbers of which day you want to pull. Once you've created these dynamic lists, there may be some duplicates amongst those. I would assume there would be. That doesn't matter. The Palo Alto is fine with that. And the other thing you'll notice is that I pull previous days daily in the morning, but I pull the current one every 5 minutes. Okay? That way, if somebody scans my network, 5 minutes later, they're blocked for 72 hours. You're done. Okay? All right. At that point, you're going to create another syslog server profile. I love this. It's lots of boring stuff. And then basically, this syslog server profile we're going to use to identify blocked attacks. okay? And this profile is going to say, okay, if something hits one of those dynamic lists, we're going to then take them, and we're going to send that information back to the syslog server so we know what's being blocked, so we can monitor that. Okay? So same thing as before, very, very similar. We're then going to go into the custom log format, and we're going to change the log to something that looks like this, which is attack blocked from source to destination, the protocol, the destination port, the application, and then I like to add on that DRK at the end so I know exactly why it was blocked, what reason it was blocked. Okay? All right, and then after that, you're going to create your custom log forwarding, another log forwarding, and you're going to say this is the blocked attack. You're going to assign it to that server profile, and you're going to push it out to the log server. And, yeah, go for it. Correct. Because what will happen is if they continue to scan that darknet, they will continue to end up on that list. Now, if they're not scanning the darknet, they'll eventually fade off of it, if that makes any sense. Okay? It doesn't continue if they're scanning the rest of your network 3 days later and they've already faded off the darknet, then it won't catch them at that point. Okay? So yeah, there are some holes. But this is a generally good practice. Okay, so you're going to create a policy rule. This is important. This is kind of the key to the whole thing, that we want to go in and we say the source, if they come from, and then you'll notice that we use those dynamic lists that we already created, darknet scans 1, 2, and current. If they come, anything comes from those, we're going to deny them, and we're going to forward that on to that log forwarding profile that we created earlier. And that's it. That's the end of it. But in the end, what you'll have is something that looks like this. So we show the scans at the top, where they're coming in, okay? And then the attack is blocked from that particular scan. And this is happening within 5 minutes of these scans coming in, they're being blocked on the rest of the firewalls. Now the cool thing, hold on just 1 second, I'll get to you. The cool thing about this is you can also, if you're using Panorama with Palo Alto, you can push this out to all of your firewalls very, very easily. And now, not only is it being blocked on one firewall, it's being blocked on 10 firewalls or however many firewalls you have in your organization. Okay, go ahead. You don't want to pull it too early, and I think that is I think that is as quick as you can pull it. Right. So I don't know. I can't remember. That's what I ended up setting it as. That's correct. So that you'll still have 5 minutes to continue scanning, but depending on how big your address space is. And the other thing is at that point, they may come back after a scan and they're going to be blocked for at least 3 days. So, okay, yeah. Yep. You know, I haven't run into that yet, but you've absolutely got a valid point, and that's why I kind of preface this with you've got to be careful what you end up blocking. Palo Alto does have the capability to do exemptions, but you're spot on. I mean, if somebody did spoof something, you'd have an issue. So, go ahead. I've had it implemented for quite some time now. Well over, I don't know, it's been at least a year more. Okay. I haven't had any issues yet. So, okay. Yes. This has not caused a problem with that. Yeah, so if somebody purposely pointed at one of my darknet address spaces, yes, absolutely, they'd be blocked within 5 minutes. So, absolutely you could, but like I said, since there are no DNS entries, no reason to ever go to that space, that should never happen in any legitimate reason, in any legitimate way, okay? That's why I said at the very beginning we talked about how do we determine what a darknet space looks like if we're using a darknet space that has ever had anything on it, that anybody would ever, if there's ever been DNS addresses pointed at it, we want to make sure that this is clean space or has been clean for quite some time so that no one would ever touch it. Oh, you mean if somebody was going in and saying, okay, they're pounding the firewall against, they got an excessive drops on the firewall in normal space. Absolutely, you could do things like that if you wanted to. In Cisco, they call that the shunning, and Cisco will actually do that automatically if you turn on the thing. It can be problematic, and because what happens is sometimes people have clients that are misconfigured and doing things that they shouldn't do, and they're legitimate people. It does have some issues, and back to, I've run into problems with that when I've used it. Can you do it? Absolutely. But if you do it, be careful with it. Any other questions? Okay, we finished early. Thank you.